Hi students, welcome to physics classes. We are discussing about motion in a straight line. In that we discussed some terms related to kinematics. Now today class we will discuss about speed and some forms of speed. To discuss speed we will take for example. Now for example two boys are there, Ram, Lakshman are running in a 200 meters race. Now Ram completed the race in 20 seconds. Ram completed the race in 20 seconds. Lakshman 25 seconds. Lakshman completed the race in 25 seconds. Now who ran faster? Obviously Ram ran fast. We can say rate at which Ram travel 200 meters in 20 seconds. 10 meters per second. Lakshman 200 meters in 25 seconds. That is 8 meters per second. So the speed of Ram is more than speed of Lakshman. Speed of Ram is more than speed of Lakshman. From this we can define speed, distance traveled by the body in unit time. Distance traveled or covered. Distance traveled or covered by the body in unit time. In unit time is known as speed. Now we can write the formula for speed. Speed equal to distance by time taken. Speed equal to distance by time taken is the formula for speed. Distance by time taken. SI units of speed. Distance SI unit is meter. Time SI unit is second. Meter per second. CGS unit. In CGS distance unit is centimeter, time unit is second, or it can be written as meter second inverse. This is centimeter second inverse. Now we have other units, bigger units, kilometers per hour or kilometer per hour, kmph. This we will see regularly in our vehicles. Now what is the relation between kilometer per hour and meter per second? Now this is a question. What is the relation between kilometer per hour and meter per second? Or 1 kilometer per hour equal to dash meters per second. Now we should convert this kilometer per hour into meter per seconds. As we know 1 kilometer equal to 1000 meters and 1 hour equal to 3600 seconds. So if you substitute there we will get meter per second. 1 kilometer per hour means 1 kilometer by 1 hour. 1 kilometer 1000 meters. 1 hour 3600 seconds. 2 zeros cancel. 5 by 18 meter per second. 1 kilometer per hour equal to 5 by 18 meter per second, and 1 meter per second equal to 18 by 5 kilometers per hour. It is very important relation. 1 kilometer per hour equal to 5 by 18 meter per second, 5 by 18. Now in the speed we have different cases. In the first one is, as we discussed, distance traveled by body or distance covered by the body in unit time. Distance traveled or covered by the body in unit time is known as speed. If a body travel from point A to B, C, D. Now A to B distance is 50 meters, B to C also 50 meters, C to D 50 meters. So to travel A to B, if it takes 10 seconds and B to C 10 seconds, C to D also 10 seconds. Now here body, for each situation A to B, distance by time, T by 10 equal to 5 meter per second. Now B to C 5 meter per second, C to D 5 meter per second. So all the distance throughout the distance it traveled, it is having same speed. It is having same speed. Then it is said to be traveling with uniform speed. What it is? Uniform speed. Uniform speed means a body travel equal distances in equal intervals of time. Equal distances in equal intervals of time, then the body is traveling with uniform speed. Then the body is traveling with uniform speed. If not, now here body travel A to B 10 meters in 5 seconds, B to C 15 meters in 5 seconds, C to D 20 meters in 5 seconds. So as the distance is changing, time is same. Distance is changing, time is same. So here body traveled unequal distances in equal intervals of time. Body travel unequal distances in equal intervals of time, then the body is traveling with non-uniform speed. Non-uniform speed. If distances are unequal, times are equal. If times are unequal, distances are equal. We will take another example. Now here body traveled equal distances but times are not equal. Body travel equal distances but times are not equal. Body travel equal distances in unequal intervals of time. In unequal intervals of time, then the body is in non-uniform speed. Non-uniform speed. Now if any one is unequal, other one is equal, then it is non-uniform speed we are saying. If both are unequal, we can't conclude that whether it is uniform or non-uniform. Some cases it may be uniform, some cases it may be non-uniform. Okay, now we will see one situation here. Now if a body travel A to B 10 meters in 5 seconds, B to C 20 meters in 10 seconds, C to D 30 meters in 15 seconds. So each situation distances are unequal, whereas as well as times also unequal. Distances are unequal, times also unequal. But if you see 10 by 5, 2 meter per second, 20 by 10, 2 meter per second, 30 by 15, 2 meter per second. So body is traveling with uniform speed here. Here it is uniform. So whenever they are different distances in different intervals of time, unequal distances in unequal intervals of time, the body, we can't say whether it is traveling with uniform speed or ununiform speed. So here if any one is unequal, we can say it is non-uniform speed. Now this uniform speed is also known as constant speed. Uniform speed is also known as constant speed, and this non-uniform speed is also known as variable speed. Uniform speed is also known as constant speed. Non-uniform speed is also known as variable speed. Variable speed. Okay. Now here if the body traveling with uniform speed, at any point if you take, its speed is same. So we can take average speed is 2 meter per second. So not increasing, not decreasing, it is going with uniform speed. So here we can take directly its speed is the average speed when the body is moving with uniform speed. If the body traveling with non-uniform speed, here speed is 2 meter per second, here less than 2, here more than 2. So speed is changing. In these type of situations, we can take average speed, total distance traveled by the body in total time taken. Average speed is defined as total distance covered by the body in total time. So we can write average speed equal to total distance divided by total time taken. Now here average speed gives for total situation. Average speed gives the idea of speed for total situation. Now for example, if a body travel one point in different instances, now 10 meters, 10 meters, 10 meters in a time 5 seconds, 6 seconds, 4 seconds, and again 5 seconds. Here if you take average speed, we'll get total distance 10 plus 10 plus 10 plus 10, 40 divided by 5 plus 6 plus 4 plus 5, 20 equal to 2 meters per second. Average speed is 2 meters per second. That gives overall idea. But it can have some situations more speed, some situations less speed, some situations still more speed. Now if you see here, first and last two situations are having 2 meters per second, but here less than 2, here more than 2. So that the speed of an object is changing instant to instant. It is not a constant. This average is not instant. In this particular situation 2 meters per second, here less than 2, here more than 2, here again 2. So it is changing. Now in that particular instant, what is the speed of the body? This can be explained by using instantaneous speed. Now instantaneous speed, speed in a particular situation, particular time. That time we can take t, speed at t time. Okay, now here if the body travel a time distance s, delta s, small distance delta s. Now this distance is traveled in the time interval from t to t plus delta t, small delta t, small time. Okay, from t to t plus delta t. Now we can take average speed in this time interval. Average speed in this time interval is delta s by change in time, delta t. Now this delta t is vanishingly small. Delta t is very small, and then distance delta s is the distance traveled in a time delta t. If delta t approaches to 0, as we seen, delta t is very small. If delta t approaches to 0, delta s also approaches to 0. So, but delta s by delta t has finite limit. Now, instantaneous speed at a time t can be expressed v equal to limit delta t tends to 0 delta s by delta t. So that can be written as ds by dt. ds by dt. Now here s is the distance traveled in a time t. S is the distance traveled in a time t. Okay, this is about instantaneous speed. Now what is the difference between average speed and instantaneous speed? Average speed is the distance covered by the body in a time interval. In a time interval. Now speed is the distance covered by the body in instant time. Average speed is the speed of the body in an interval. From one point to another point, it's speed, average speed. Now coming to instantaneous speed, in a particular instant, in that particular time, its speed is, that is instantaneous speed. Thank you for watching. Please subscribe for more updates.